All right, ladies and gentlemen, today we are looking at the basics of solving equations. Your goal in solving an equation is to transform them into x, or whatever variable you have, equals a number. That's really all you're trying to do. Now, the basic idea here is that we need to understand what that equal sign means, and then we need to understand once we understand what the equal sign means, how do we allow the equation to retain its meaning? So the basic idea is this. An equal sign means this side is the same as this side. Okay, now that doesn't necessarily mean they have even the same things, really. Imagine you go to the store and you're told that a candy bar costs $1. Well, you have $1 in your pocket. That dollar is really the same value as the candy bar. You could either have the candy bar or you can have the dollar. Okay, either way, that's the same. That's kind of what we're talking about here, because on one side you might have variables and things, another side you might just have numbers, but their value is the part that's the same. Okay, and the basic concept here is if they're the same, I like to think of it as balance. Okay, so let's say that we have the equation x plus 2 equals 5. That means if you take the value of the variable x and you add it together to 2, the value of 2, you will get a value of 5. Another way you could look at this is we've got a mystery box that has a value of x. Then we've got two little boxes that we know weigh exactly 1, and they're on the left-hand side of this balance. And then over here, we've got 5 boxes that all weigh exactly 1. This would be a great way of looking at it. So if you wanted to figure out the value of x without changing the balance, that's the problem. You can't change the balance. If it's no longer balanced, you don't know what x is. Okay? The way to do that would be, well, I can remove these 2 boxes from this side, and if I remove an equal weight from this side, I should have some balance. And I get that, oh, okay, when I have 3 on the right and I have x on the left, I get the same thing. The whole idea is balance. The way that you keep balance in an equation, or the way that you allow that equal sign to continue to be equal, because again, all of that equal sign means is that the value of each side is the same at the beginning. Okay, all it means is that it's the same right from the very start. If you add 10 to one side and don't do that to the other side, now that one side you added 10 to is going to have a value bigger than the other side. The balance is no longer there. So you have to make sure you retain balance. The way you do that is by doing the exact same operation to both sides. So as long as you do the same thing to both sides of an equation, it'll stay balanced. If I add if I've got a equal amount of money, okay, I've got a dollar bill and I've got 4 quarters. If I add 5 cents to each pile, they still have the same amount of money. If I subtract 5 cents from each pile, I still have the same amount of money. Okay. Now the key is, what should you do to both sides? Well, the key is you want to be doing the opposite operation. So I'm going to put up. I'm going to go with 4 different examples here. All of them are going to use an x, a 2, and a 6. And what I need to realize is, what are my opposite operations that get me to where I need to be? Okay, so I want to try to transform this into x equals a number. Well, in this first one right up here, I have a value x, and I'm adding 2 to that value and getting 6. I don't want this here anymore, because I want to have just x on this side. Well, to get rid of a plus 2, I need to do the opposite operation. Opposite of addition is subtraction. If I subtract 2 from both sides, 2 minus 2 is nothing. And I get that x equals 4. I did the same operation to both sides. Since I subtracted 2 from both sides, the equation itself must still be true. And I could go back and check. 4 plus 2 is 6. That works. Try writing down what you think the opposite operations would be that cancel the 2's, that get rid of the 2's, that get us x equals a number in each of these 3 equations. So try it out, pause, and then come back when you're ready to see the answer. So I'm assuming you've done that already, and in this one we would add 2 to both sides. If we subtract 2 from x, we can cancel that out by adding 2. That's the opposite operation. If we do it to both sides, we retain our balance. Sure enough, our answer of 8 minus 2 equals 6 checks out. Here, this operation is multiplication. You get rid of multiplication with division. We get x equals 3. Last one's a little tricky. You got to remember that fraction bar means division, so if we multiply both sides of the equation by 2, multiplying and dividing by 2 cancel out to a nice 1, and 1 times x is just x. So we get that x equals 12. Those are your opposite operations, okay? So all you're doing to solve these simple one-step equations is you are completing that opposite operation, okay? I'm just going to throw a couple quick examples on here. Why don't you guys try them out? I'm going to write 3 examples up here. Try each of them out, and then come back when you're ready to see the answer. Here's the 3 examples. Okay, why don't you try those 3 examples and then come back when you're ready to see the answers. Pause, come back. All right, you're back. Welcome. This one we should add 6 to both sides. Negative 2 plus 6 is 4. Here we're dividing by 5. We should multiply by 5 and get x equals negative 50. And over here we should divide by 5 and get x equals negative 2. I really would like you to show your work in every equation that you solve, especially early on. You can get to the point eventually where you don't necessarily need to show that you added 6 to both sides. We'll assume it. But for right now, practice showing that work, so we can make sure that you're retaining balance, because that's one of the biggest places people go wrong is they'll forget to write down the plus 7, but then they'll only add it to one side of the equation and they won't do it to the other. It seems like you won't make that mistake now, but that's because we're looking at very easy equations. As we get to harder and harder equations, that won't necessarily be true anymore. That's it for today. So again, just keep those opposite operations in mind and always remember to keep things balanced.